Question number 5. Consider these two lines of parametric equations here. We want to find the point of intersection between the lines and equation the plane that contains both lines. So our two lines, x is equal to 2t, y is equal to t plus 2, and z is equal to 3t minus 1. And the second line is x is equal to 5s minus 2, y is equal to s plus 4, and z is equal to 5s plus 1. Now let me just point out here, we're using different letters as the parameter in these two lines, and that's a good thing because we're going to be solving equations here, and if we wrote t here, the values of t that these lines intersect at could be different. So we do want to use different letters here. Okay, we have three equations. X is 2t in the first parameterization, but is 5s minus 2 in the second equation. Y is t plus 2 in the first equation. It's s plus 4 in the second equation. Z is 3t minus 1 in the first parameterization, is 5s plus 1 in the second parameterization. And so now we have to solve the system of equations. Okay, there's many different ways to do this. Going to do some substitution here. If I solve the x equation for t, I get t is equal to 5/2 s minus 1. And then I can plop in 5/2 s minus 1 into the y equation to get 5/2 s minus 1 plus 2 is equal to s plus 4. Okay, simplifying this, we get 5/2 s minus 1 plus 2 is plus 1 is equal to s plus 4. Combining like terms and such, 3/2 s is equal to 3, so s is equal to 2. And if s is equal to 2, t is equal to 5/2 times 2 minus 1 is equal to 5 minus 1 is 4. So we came up with t is 4 and s is 2. But now we need to check the third equation. So t is 4 and s is 2 satisfy the first two equations. Let's check the third equation here. 3 times t is 4 minus 1 is 5 times 2 plus 1. And yes, both sides of those are 11. So you should always check this third equation. Sometimes I think there needs to be like a bloopers outtakes reel for these videos. The first time I recorded this video, I made a computational mistake. I came out with a different set of t and s, and as a result, I was able to catch my mistake. I caught my mistake by realizing that I wasn't satisfying this equation, so that told me I needed to go, and there was a mistake there. Okay, it's okay to make mistakes. It's okay to make mistakes here as long as you can think to yourself, be able to catch your mistakes. Okay, so the point here, no pun intended about the point of intersection. If we plug in t is equal to 4, we get 2 times 4 is 8. 4 plus 2 is 6. 3 times 4 minus 1 is 11. And we plug in s is equal to 2 down here. 5 times 2 minus 2 is 8. 2 plus 4 is 6. 5 times 2 plus 1 is 11. So this right here, 8, 6, 11, that is the point of intersection between the lines. So then the second part is find an equation of the plane that contains both lines here. So for an equation of the plane, we need two things. We need a point and a normal vector. We have the point, 8, 6, 11. We need a normal vector. How do we do that? Well, we want direction vectors for each of the lines. So a direction vector for this first line is simply we just write down the coefficients of t in the x, y, z components. So 2, 1, and 3. And then direction vector for the second line, the coefficients S are 5, 1, and 5. So 2, 1, 3, 5, 1, 5. These are two vectors, so that lie parallel in our plane. So like here is V1, here is V2. This point right here is our point 8, 6, 11. How do we find a normal vector? We take the cross product of V1 and V2. Okay, so let's do that. Let's do that. We would end up with, so V1 cross V2 is I hat, J hat, K hat times, so 2, 1, 3, and 5, 1, 5. So I hat times 1, 3, 1, 5 minus J hat 2, 3, 5, 5. I'm just, for this, I'm just covering up the top row and first the first column, second column, then I'll be covering up the third column here. 2, 1, 5, 1. So I hat times 5 minus 3 is 2, minus J hat times 10 minus 5, 10 minus 15 is negative 5, plus K hat times 2 minus 5 is negative 3. So our cross product here is 2I hat plus 5 J hat minus 3 K hat. Before we do anything else, let's check to make sure that our cross product is good. This needs to be normal. This needs to be orthogonal to both 2, 1, 3 and 5, 1, 5. 2 times 2 is 4 plus 5 minus 9. 4 plus 5 minus 9 is 0. That checks good. 2 times 5 is 10 plus 5 is 15 minus 15. That also checks out to be 0. So this is great. So we have our normal vector and we have our point 8, 6, 11. And so from this, we can simply write down our final answer, which is first coefficient comes from the normal vector 2 times x minus 8 plus 5 times y minus 6, minus 3 times z minus 11 is equal to 0. And that's how we solve this problem.